dimethylcyclopropane. So propane looks like this. So if we had to add two methyl groups, we could add them in various ways. So the first form is we could do this. So let me write the four isomers. So the first form is we could put the methyl groups on the same carbon like that. This would still be dimethylcyclopropane. This would still be dimethylcyclopropane. Another possibility is I could put one methyl group there and one methyl group there. Right? I know if I put a methyl group there and a methyl group there, it's still the same thing, right? But then I know that it's also possible for me to have one coming towards me and one going away from me. That's also an isomer, right? And then it's also possible for me to switch Therefore, those are our four isomers. But then someone might ask, why is it that we haven't switched this one? For these two compounds, we're able to switch. So I said you wedge one, you dash the other. You dash the other, you wedge the other one. So why was it allowed here and we did not do it here? So the reason is quite simple. When you look at this structure is an example of a compound we call a meso compound. Whenever you have meso compounds, so one thing you'll be able to see is this structure and this structure are the same. So if you look at it from a three-dimensional perspective, one thing you'll be able to see is these methyl groups are sticking out, right? They are on the same side, they are cis to one another. And then when you look at these are also cis to one another. These ones are at the bottom, these ones are at the top. These molecules are the same. The only difference is that you've just rotated the molecule. So it's literally upside down. This is why we do not consider these isomers. So they are the same compound. So that's why there are four possible isomers. So the question wanted us to draw three-dimensional structures. So all you need to do is try to represent this in a three-dimensional manner. So you do that. So you have your CH3 like that. You've expressed, you've shown the first structure. For the second one, what you just need to do is you draw the compound like that, and then because they're coming out of page, you can also show the invisible hydrogen there. Like that. And then here you have the same situation. So that's our methyl group. And then there you have your hydrogen there. If you wanted to, you could show these hydrogens there. And then C, when we look at C, how does C look like? So we have one methyl group that's going out of page. But okay, so and then we have another hydrogen group there, and then we have one that is going that way. Oh, it's the one we've dashed, huh? And then we can also have a hydrogen group there, like that. So CH3, and then D. So forgive my drawings, they're quite rough. So when we look at D, we have one that's coming down, CH3, and then we have a hydrogen there. We have this methyl group, and then we have a hydrogen there. So you've expressed this in a three-dimensional manner just by doing that. The next part wants you to say which ones are enantiomers. So these two are enantiomers. So if this was A, B, C, and D, C and D are enantiomers. So how do I know? You'll be able to know because these non-superimposable mirror images of each other. So these ones will be enantiomers. And then another thing that they want us to do, another way to know whether it's an enantiomer or not is to identify the chirocenters. So if you look at this one, how many chirocenters are there? So when you look at this is not a chirocenter because they're two similar groups. Here, this is not a chirocenter. Here, this is not a chirocenter. Therefore, this is a chiro. Alright, look at the second one. This is a chirocenter. That's very true. And this is a chirocenter. But because this is a meso compound, the overall chirality is 0. So therefore, this is a chiro. When you look at this one, this is a chirocenter. This is a chirocenter. And then, so these two have chirality. Therefore, they are enantiomers. So having done that, we only have one question left. So the question said, what's the general formula for alkanes? I'm sure we already know that one. So that would be CnH2n plus 2. So that concludes test 1.